Hello everyone, it's Schmidt from Rocket Lasso, where we make plugins, tutorials, and live streams. And speaking of live streams, it's important to note that next week, a week from today, on Wednesday, is going to be episode 1 of season 4 of Rocket Lasso Live. And Rocket Lasso Live is a show where I tackle questions straight from the audience live on Twitch and on YouTube, where we just try and figure out different parts of Cinema 4D as we go on the fly. Again, a week from today, and that is March 30th. But today we are going to be tackling practical uses for nodes that you can do right now. There are a lot of different elements to dive into here, and we'll even be doing a little bit of Redshift as well. So with so much to cover, let's dive right on into a brand new scene file inside of Cinema 4D R25. Some important context as we get started here. For the last several months, Rocket Lasso has been working closely with Maxon in regards to the scene nodes. We've been diving really deep into them and giving our feedback about the places we'd like to see it go and the types of things we'd like to be able to create. And while doing that, we've been creating some different assets for Maxon, and you should have been receiving those if you have the newest version of Cinema, R25, and that's because we're using the newest nodes, which means it needs the newest version. So in your assets browser, Maxon has been shipping every month new objects, new models, new materials. And along those lines, they've shipped 2 of our tools so far, and you can find them by searching FUI. And we've got 2 of them so far. We've got the grid and we've got the brand new FUI graph, and that should have only shipped in the last week or so. So to start out today, I will be stepping through some of the parameters and options and power of these new tools that we created. I think they're actually pretty fully featured and very powerful. So starting with that and then getting into some Redshift rendering and then using nodes directly as capsules and then eventually making our own capsule is the goal today. So to begin with, let's drag a copy of the grid in as an object, and you'll see that it is essentially a spline primitive. In its most basic form, the grid is a series of lines going across to create a final singular spline object. If I make this editable, you'll see it's returning a single spline object. But that is made of a series of segments that right now is a full line going from one side all the way to the opposite. Currently, it's set to endpoint mode. I'll shift that over to per step, and I'd like these to be 50 by 50 by 50. So every one of these cells is exactly 50 large, meaning I can change the count by increasing the X count or decreasing it. And then we have the Z count, increase or decrease it. It starts getting more interesting though when we add in some Y count as well. So this is 0, but we say there is 1, and now we have a 3-dimensional grid, increasing that all the way up to something like 10. Let's go default. And now we've got a 10 by 10 by 10 grid, making it fully 3-dimensional. We can make that 2D again, a different orientation by dropping one of these down to 0. So now it's on the X orientation if you were so inclined. And then let's jump that back down to 0 so we can look at a couple of the other options. Currently, we are in the type of line. It is the most simple mode that we've got, where the line goes all the way from the left to the right. But we can shift that over to segment mode, which out of the box is not going to look any different. But if I increase the gap parameter, we can put a gap in between the lines, and you see instead of one giant line from one side to the other, they are split apart everywhere that they crisscross each other, everywhere they intersect. So with that gap, we can now see the spaces in between, see every individual segment, and of course, still make it 3-dimensional if we're inclined. Set that up, and we can see the gaps there. Make the gaps even larger by increasing that, making the lines really thin and small. And we can see how that fills out this entire space. Let's simplify by dropping back down to 0, and I'll get rid of the gap again. You can reset your parameter always by right-clicking on the arrow on the left or right. So right-click sets it to default. Switching this to the final mode, or the final type of box, every cell now, instead of being an individual line, is now, and you'll see it as I increase my gap, is now an individual rectangle. So the entire space is filled by individual rectangles. Again, we can make that 3-dimensional, filling up this overall space and creating a lot more opportunities, in this case, for extruding or creating a loft, just filling up the overall volume. Simplifying one more time, let's drop this down and take a look at this return setting, in which I can say I only want to see the outside of the grid. And I can also do the opposite of the inside. So yeah, the outside, kind of like a Monopoly board, the inside being everything except for the outermost one. But these behave even more differently depending on if you are a 2-dimensional grid or a 3-dimensional grid. So if I were to go back to full and increase the cell count a couple here, now when I click, I would like to see only the outside. You'll see that only the outer walls are revealed and the entire interior is empty. The opposite being, let's go to a different mode. Let's do the segment mode, and you can see only the outer walls of that one as well. I could say, how about just the inside of that? And we get the exact opposite. So now instead of the walls, now it's all of the interior, and all of those can be combined in any way that you can see fit. But in order to move forward and see this kind of visualize a little bit more, we need to move into Redshift. First, I'll give that a save, paste that in here as basic grid. And now let's pop open some Redshift. First of all, we'll need a material. So clicking on the material flyout, then create Redshift, materials, material, brand new Redshift material. Let's apply that directly. And then open up a Redshift render view. As that pops open and we hit play on that, we see that there is still nothing being rendered. And that is because currently that's a spline, and splines don't render by default. By right-clicking on it, I can add a Redshift object tag onto it. And by default, if this is a spline, it will detect it and open up this curve tab. With the curve tab, I can say the mode should be enabled as, let's say, hair strands. And the instant I turn that on, now it is actually able to render at that spline. And I do like rendering at splines because it can actually render incredibly quickly depending on your setup. Let's go and start making this a little bit more complex. Making a second grid. This one, I'll say I would like to see it from the outside. And now we've got an outer and an inner. If we wanted those to be different colors, though, we'd start needing to make multiple materials. But here's a trick I really, really love doing inside of Redshift. Instead of making multiple materials, what if I grab both of the grids, go to the basic tab, and say the display color will not be material, but instead be custom. So selecting the first one for the inside, let's make this sort of a orangey color. And then on the other, let's make it a pinkish blue color. So we got two different colors directly on the object. But of course, that's not reflected here in the render. To do that, we need to go into the Redshift material. I'll make that nice and big. And let's search for the word user. There is a color user data there. Dragging that in, I could set that to output something about the object, an attribute. Which attribute? Well, that will be the object's display color. So that is now outputting the color of the object. What would we like that to feed into? Well, into the Redshift material. Currently inside of here, we've got some basic color and the diffuse. I don't want that. And we've got some reflection. I don't want that either. So now it's just a fully black material. But inside of overall, I would like it to become an emissive material. So that can be fed directly in to the input as the overall emissive color. And now if I move this away and let's refresh that. And take a look at, we need to give this some weight. So let's set that up to 1. And now instantly we can see that we got exactly those colors on the object. So one material, and let's just call this glow. One material, two objects, but we're able to see them clearly just by changing their display color. But here's something that I like to do. I like to get a little bit of glow going onto these materials. So let's make it overly bright. And sometimes I can go overboard. So let's try going a little bit easy on it. I'm going to say an emission strength of 10. So it's 10 times brighter than normal. Now, immediately you see these start getting oversaturated. They're getting really bright. Now, what we could do is let's grab that outer one and make it darker. So I'll select it and start pulling back on this color. You can see we can get back into a reasonable range where it's not blowing out. But we'll leave the inner one nice and bright. Closing down this material window, let's open up our render settings, Controller Command B. And inside of there, renderer will be set to Redshift. And right-clicking, I'll create the Redshift post effects. So it won't look any different out of the gate. And I'm not an expert in these, but let's just play around and see what we can get. Under bloom, that should give us a nice looking glow. Enabling it, it won't look any different because currently the threshold is all the way up at 20. And we know that that's glowing up to 10. We can try setting that down to 10. Yeah, we get a little bit of a glow going on there. We can set the threshold even lower if we want, something like 5. So at that halfway point, we're going to start getting a really solid glow depending on how bright the object is. Now, that can end up overly bright. So just playing around some more. Under exposure, I can enable that. And mostly playing around with this tone mapping, I could increase the black crush amount and we can begin pulling back on how dark certain areas can be. And let's go to the crush threshold as well. I can crank that up more. And now this is starting to feel like a pretty nice glow overall. Closing that down, let's just play around with making some additional grids, giving that a quick save. We'll be fighting for a bit of screen real estate here, but I'll scoot that up to the upper right corner, shrink it just a bit, and let's play around with the grid. So with the different colored grids here, let's start layering them up. Keep it nice and simple. Delete that. Let's just go with a single grid that is full and set it to 0, so it's just laying there on the ground. And we can even go back to the basic line. So there's a basic line grid. And now, let's see, how would I like to do this? Let's make a duplicate. And this one, I'd like there to be way more. Let's make this be divided by 5, which would set it to 10 by 10 by 10, which means this has to jump up times 5 instead of divided by 5. And then you can see I've got 5 times as many grids there. So those are overlaying each other, looking identical, but let's change the way those look. Let's make the secondary one a different color. Make it a bit darker, go into the red, maybe into this bluish color. And let's make the line a lot thinner. So set that down to 0.2. Yeah, look at that. So now we've got 2 layers of grid on top of each other. Now in the viewport, those are going to look barely distinguished from each other. But now when they overlay inside of the render, we're starting to get something a little bit cooler looking. So creating a duplicate of that very first one again. What would I like this time? Well, let's make it a box outline. I'll say just the outside. Shrink that in via this gap. And yeah, look at those begin to layer up and just starting to make different, like I said, FUI elements. We can layer these up however we like. How about making a giant copy of that one? Let's set the we'll set the color late. Let's add a couple of additional layers there. Maybe only a little bit of a gap. Actually, let's change that to a segment. Add a little bit, like a little distance in there. And now those are layering up nicely. We got that right in the middle. Then on that, I would like, let's make the line thinner. So we'll go back to another 0.2. So those get nice and thin. And let's go on the opposite end of the color spectrum and set the color to a darkish purple. Just have it barely show up there on the outside. Then if we wanted, let's make some interior of a grid. Make another duplicate, set it to the opposite. That one will be the inside. That's filling in the inner part. Put no gap in there. And let's go with a lighter blue just for fun. And yeah, we get those inner lines. And that one I want to be very faint, so I'll make that darker. And just fill up that space a little bit. Yeah, that's looking pretty good. And possibly even thinner, so 0.1. And right now, I'm just going through and playing around doing different looks. We've got this outermost grid there. Make a duplicate of that. And let's say that should be just boxes. And now we've got boxes filling up the outside. That looks pretty good. I would like it to be thinner, so set that to another 0.1, just barely filling up. And now let's actually full screen that, take a look and click the bucket render, see what the final style looks like. So just by layering up a couple of these different grids on top of each other, we can create a lot of different looks, like a lot of different FUI elements that could be really fun, and just used in conjunction with other things could become really, really powerful. Let's stop that render for a little bit and even close it. At any point, this could become real geometry. Let's drop this just back to the original grid, set that to a box. That could be fed into a loft. So now we've got that as geometry. Instead, that could be fed into a extrude, and now we can get thickness on that grid and continue to layer them up as actual geometry. And of course, I love throwing these types of things into, let's do a volume builder and a volume mesher, and drop that down to something a little bit more detailed and a little bit thinner. Set that to 5, set that up to 10. And now we've got a flat blobby grid that should be eating up all the space. Clear to select and add additional volumes to it and create these different cages. So yeah, pretty fun to just play around with this. We can see just the outside to make it hollow, just the inside and get the interior of that shape. That's the box shape. It's changing that over to the line, giving a completely different look. Lots and lots of fun ways of layering these things together. So that is the grid. Let us delete all of that. I'll just keep the original grid so we can steal some elements from it and move into taking a look at the other FUI tool that just came out this week, and that is FUI Graph. I'm going to be making the assumption that you haven't seen too much about the FUI graph, so let's step through it and see it in some detail. Close the asset browser. I'll steal these tags for later, and we don't need the grid, so I'll delete that. And take a look at this graph and see what parameters we have to play with, and there are quite a few. The core concept when it comes to graph is the ability to generate some random data modify the data, and then display it as a graph. And we'll begin here. There are 4 different types of graph. We've got the bar graph, and then jumping up to the line graph, and you see that perfectly matching the pattern, and then a step graph, again matching. And finally, the pie graph, which is really cool, but we can visualize the data best if we stick with bar graph, even though pie is my favorite. We'll get to that a bit later when we're playing around. So sticking with the bar graph, we've got some basic settings here, the exact count here. And because we're seeing a noise represented, this essentially is like the resolution of that noise, like how often is it being sampled. Then we can change the alignment, left, middle, right. Then the straightforward width, and it's always going to be exactly that width. Then we've got the set height of the data. Then we've got some rounding, which was a suggestion by a beta tester, which I really like. Really adds some style to these, like just a little bit of rounding. I feel like, stylistically goes a long way, and then you can crank that up and cover all of them, just making it feel nice and rounded and bubbly. Then we've got the gap here, spreading that out. We can set that up to, let's say, 5, and there's exactly 5 units in between each piece of data there. Resetting that. We have shift. Currently, all the data is starting from the axis and moving up, but I can shift that downward, and now the data goes down. And even more fun is leaving that in the middle. If I crank up the resolution, with different noise types, you can actually visualize some cool looking waveform type things. Setting that all back to default. We've got the plane that it will be laying down on, and then output, but we'll talk about that in a little bit. Let's move on to some data. To begin with, we've got a manual mode, a noise, a random, and a spline. We're not going to cover everything because there's just a lot of settings, and I should have a full video covering all the different parameters on here on the Rocket Lasso YouTube channel. So for now, let's do a simple one like random. Inside of random, we are generating random numbers. Those are doing the full width of 400 and the full height of up to 100. So we can change the way those look by changing the seed, changing the minimum value that those might be, the maximum value they might be, shifting the values all up or all down, and then biasing them, essentially increasing the contrast of that. So as I crank that up, even going beyond 100, we're saying they're all at 0 and all at 100%, pretty much no in-betweens. And of course, these all combine on top of each other. And then there's a width variation. So as I drag that up, we're going to get variation in how wide each of these are. We still have exactly 100 data points, but they can have different widths applied. So let's just jump into the most fun one, and that is the noise input. So by default, we even have some settings turned on that make this animated by default. By hitting play right out of the gate, the graph will animate. Now, the first thing to point out is we've got a different random seed. We can cycle through those. We've got the different noise types. So I could jump this to any type. Let's jump this to a Luca, which tends to be nice and messy. We see that moving across. And then we can start moving into the different specific settings like the noise scale. So I can crank up that noise scale, make it way larger. You can see it scaling there from the left. And as we get larger, we can see that be a little bit more consistent. Meanwhile, I could set that really small, let's say like 0.1, and now it's so small that essentially we don't see any continuity between any of them. Where at 1, you can usually see a decent amount of continuity. Next up is the octaves. Drop that down and it'll be less detailed, and you can crank it up to have it be more detailed. But usually the default of 5 is what cinema noises typically are at. And next up is the speed. The speed is the speed that this is currently animating at. So I could set that really slow, like 5%, and it's just barely moving. And we could crank that up to 500, and it's going to be going so fast you can't even see what's going on. But where things get pretty fun and interesting, and this took a bunch of effort, is we've got the loop frame. So we can type in a frame that we'd like to loop at. So right now you see a pop right there. You see right when you get to 90, there's a big pop. But if I set that loop frame to frame 91, which will be one frame after this ends, then now you'll see as this gets to the end point, it'll perfectly cycle back around and we get a perfect repeating noise. So that's pretty exciting right there. Next up, we have an offset of the data. Let me simplify this back to something like the Perlin. And this offset speed, let's set this up to say 25%. And now we're going to see it moving to the left. Now there's no way to loop this value. We tried really hard. There's no way of getting that perfectly looping. So keep that in mind. But yeah, now that is offsetting to the side. We could set this up to larger values, say 180. Let's loop up at 181 on the regular noise. And now you can see the pattern traveling to the left. So we'll just leave it at that. We could change the speed to be something negative, traveling the other direction. And any noise that we feed here can look pretty cool by getting some different noise animation and some different speeds going. Like I said, we get some cool looking waveforms. If I stop the speed from happening there and let's quantize the speed, you can see that data starts moving across really smoothly. So then in the graph, if I set that shift to 0, we now get this pattern traveling just to the left. But if we wanted it animated, let's reset that up. And now we see those animating. Crank up that speed even more, really get those moving up and down. You can immediately start seeing some possibilities and crazy combinations you might be able to get with this. Setting that back to the default, turning off that offset speed and slowing it down. And let's change back to a basic Perlin noise. Next up is the same settings we saw inside of the random. So we could change the minimum and the maximum and the shift and the bias. We already covered those in the other one. And then moving into horizontal, I can crank up the horizontal randomness. So you can see here, and actually let's go slow. This is sampling the noise to create some random width. So scaling all of these. So if I give this same noise on the horizontal some speed, let's jump that up to 25%, you can see those waves traveling left and right. It visually gets a little bit trippy because the large ones will start eating up a lot of space, and then the tiny ones will start eating up a smaller amount of space. So you kind of get this exponential moving left and right. Where I think this starts looking cool is if we set that noise scale to be really small, let's say 0.1, then now they're essentially all randomized and we get this really nice fluid motion, just kind of like waves shifting around. Now, this also has a loop point, so I can set that to 181, and we should again be at a perfect loop point. So when I hit 180, there isn't any kind of a pop, and it's just continuing to generate that data. So yeah, I really like the noise. There's so many different combinations we do just by changing this to different noise types. Now, let's go and just start, well, I guess there are some additional settings. Let's move into modify data, and we can sort the data. So I can sort by the width, and now you can see that we get the wide ones on the right and the skinny ones over here on the left. We could instead sort by the height, and now they are in perfect order moving upward. We can shuffle to completely randomize them, and something I do pretty often is set it to shuffle. Flip will just reverse them. Flip will flip it up to the top, so it's inverting the data, essentially 1 minus the data. And then reverse will flip it left to right, and we can offset the index. Let's not worry about that for now. And we've got a seed for the shuffle, so we can just randomize how that looks. And then let's give that a pause and look at, well, let's go back to regular. And then twirl down our data multiplier spline. And with this spline, I can go and drag down these different points and multiply the final value that we're seeing by this spline, which actually adds a lot of power. If you want things to fade out left to right, it really can clean that up for you. And it's really any pattern. And it's really any pattern that we want to put in here. Let's mirror that, right-clicking and say, let's deselect all, right-click and say flip vertically. And that's going to do the inverse. And now you see it dips in the middle. And that will still animate with that down on the bottom. So let's pull this all the way to the top. And there we go, looking awesome. So at this point, let's just have some fun with it. You've seen some of the basic overviews of the way that this works. Moving into the overall graph, let's take a look at some additional options. Right now, we are just seeing this bar graph as a bar graph. But we could say, you know what, instead of seeing thickness on here, let's return it as individual lines. So now we just get those little lines. Instead of lines, let's say I want to see, actually, here's what I'll do. I'm going to duplicate the entire graph, and the second copy of it, I'm going to set the output to be a rectangle. And now you're going to see that there's a perfect rectangle sitting on the top of the other graph. By grabbing the V line, I can push that all the way to the top. And now you can see I've kind of got this topper shape that is resting perfectly on top of the bar graph. Now I could push that a little bit beyond if I wanted to. We could pull it down. I can add some rounding. Actually, wrong setting. I can add some rounding to round those out. And immediately you can see how these can start combining in some pretty crazy ways. Selecting that very first one again, let's set that to line mode. Now we got lines, each one with this rectangle sitting on the top. Instead of rectangles, what if they were circles? And now there's a little circle sitting on the top. Let's change the V line to be at 100. And now perfectly sitting on that line are those circles. Continuing to combine these in different ways, we can change the number of sides on the circle, drop that down to 3, and we get this perfect triangle sitting on the top. Jump it back up to something larger. We could generate just a line, a perfectly flat line on top, which is going to be good for cloning onto, like cloning onto the center of the line or the start of the line or the end. But even just by itself, I could turn off that first main graph. So just turn off that checkbox. And now you see we just get these dashed lines as our final data. Moving, I'll select both so that they're synced up. Inside the data, let's start giving it some speed off to the side. And now those will be traveling along. Maybe the second one goes back to being a circle. So those will be circles, and those circles will look like they're traveling to the left side. And these two should still be perfectly synced up on top of each other. Selecting both, so the settings are changing together. I could decrease the count of these so we get larger or smaller. Grabbing the data. Let's turn that first one on, because without, you can lose the data. That's why I like the bar graph. It really shows you exactly what the data is doing. So if I turn that bar graph back on, you can see these perfect circles sitting on top. Again, we've got the V align, so I could center those directly on here, or even move it down so they're pivoting inside of the grid. Having done that though, we could do something like select both and set the data to just be maximized, or even let's grab the max and pull it all the way down to the bottom. So now you see all of those are lined up perfectly. Hitting play, we get all these little circles now that are just perfectly lined up with each other. Meaning if I grab that second one and say the graph's V-align is at 0, they'll all be perfect circles all lined up on top of each other. By changing the data types or even the horizontal data's variation, we can start making some of them larger and some of them smaller and start making it like way crazier. Like I have no idea how I would make this otherwise. Turning off that first graph, you can just see these nice circles filling up the overall space. So much fun to start combining these into different crazy graphs, just generating different random datas. Let's turn that off and go back to the original one. We should increase the max so we actually see the different data going. Let's slow down that horizontal movement and even get rid of all of the horizontal. I'm just playing around now, just messing around and seeing what types of things I can make. So yeah, with all of those aligned, that's looking good. Let's move on to a different chart type. I mean, there's a lot of different combinations we can do here by creating this step. And then let's go back into the data and put a lot of that random variation again. And if you start putting in enough variation, you could almost start getting like a skyline look. So let's move into the modify data and I'll shuffle those so they're now random. And look at these kind of cool looking buildings that we end up getting. Maybe we don't want so much variation. There we go, pull back on that a bit. And then when it comes to the line graph and the step graph, I am able to click this close button and it's going to seal that off. So it's something that could be extruded or that you could feed into a loft and actually turn into a piece of solid geometry. So there is a skyline, and in the data, I could just keep on hitting a different random seed and get different looking cities laid out. By remapping the data in all sorts of different ways, we could shift all the buildings up, we could pull them down, so we just see the tops poking out, so you get this nice flat level ground on the bottom. So many different combinations there. Back into the graph tab, you already saw the line mode. Let's not randomize the data, so I'll put that to none, and now we can see that nice clean line starting to emerge again. Don't close it. We could increase the resolution and now you really see the way that that noise is being displayed. And that is a Perlin noise with a lot of variation in the width. So let's get rid of that variation. And you see that nice smooth line traveling along. So yeah, now we get that nice smooth line, decrease the resolution a bit, and then make a duplicate again. And that duplicate, we could again put that as a circle. And now we get these perfect circles on the line. So many different combinations. So we don't want to spend all day just on the graph. It is a lot of fun to play with, but let's just spend a moment, of course, in the pie graph. So shifting over to pie, it looks kind of crazy starting out. So if you want it to be like your kind of standard pie graph, let's decrease the count to be pretty small. And then with the data, you'd probably want to maximize, let's pull the min all the way up so we get the full radius. And you see we now have a radius of 200. So with that full pie graph, if we randomize the width of the data, the horizontal, now we can get different random slices. So it's kind of like your basic pie graph. And keep in mind that this is the same data no matter what mode we're in. So if we click on the bar graph, this is what we're kind of mapping around the pie graph. Moving in, let's add some of that height variation back in again. And now we end up with something like this. Hitting play, we can see those animating around, and man, that starts looking so cool so quickly. Like look at this as sort of a random FUI element. Now we can get rid of that horizontal, so now we just have an even, each of these has an even width back into the graph. We've got the ability to change the start and end angle, so I could pull back on here. We could remove 180 degrees and just get them up on the top. Increase the count and get a whole bunch of those. Back into the modified data, we could shuffle those and get total randomness. So many ways of combining these things. I love the bar graph. I love the pie graph. We can, there is an inner radius setting. We'll see that a little bit better if I decrease the count again. And now everything's butting right up into the center point. But if I add some inner radius to it, you can see that they are now starting at a set radius, in this case of 57. So we get that nice inner ring. We can then shift the data to their outermost point. And you see that will shift. So instead of pivoting from the inside of the data, it'll shift to the outside of the data. It's behaving exactly like the bar graph. It's shifting from the center point being at the bottom to the center, or the axis being at the top. So doing that in the pie graph, you can see how this is now pivoting from the outside. Very, very fun. Increasing the count as much as we want. Shuffling, changing the noise type. Let's go back to Luca to make it super crazy. So many crazy combinations. And in the output, we've got all those same options still. So I could turn on that line mode. You see we get these dashed lines shooting in. We can set that to just the rectangle. And actually, they need to be pivoting from the outside to CF. So now you can see all these lines moving in and out. Let's, again, duplicate the graph and say one of them will be the line and the other one will be these rectangles on the outside. Tell them to be pivoting from the outside. Now we get these perfect boxes on the ends of the line. Selecting both of them, let's add in some of that random horizontal data. And now you get these nice wide, I'll slow it down a little quick. Yeah, because it's Luca. So slowing those down, you can see how each of these can get way wider, way smaller. Look at this crazy combination of data. Selecting the second one, let us shift that to be a circle. So now it's creating circles on the tips here. And then, of course, we can create the lines, which in this case will be little arcs on the end. So many crazy combinations. Now, opening up a folder that I've got. There are going to be some demo files included inside of the asset browser. They haven't shipped yet, so they're not quite there yet. But I've got some renders of some of the different layouts. So these are some different scene files that are going to be included in the asset browser. So let me make sure they actually open up in the proper window. So here is a bar graph example set up already with Redshift. And then let's pop open this pie graph. That scene file included. Next up, we've got a line graph. I really like this one. Very simple setup with a cloner. That one perfectly tiles and loops as well. Then we've got a step graph. Here's a bunch of step graphs inside of another cloner. And then finally, another step graph that I just kind of like the look of. And you already saw a couple things that looked a little bit like that. So yeah, combining Redshift along with these graphs, a lot of opportunities to create some pretty crazy, unique combinations. And there's a really fun tool. Like there's a lot going on inside of this asset. So many different nodes to create this and the different types of data and the different types of graphs. So I hope that as long as you have R25, you should already have it there. It should have already downloaded inside of your asset browser. Just search for FUI and it should be there ready to rock and play and make some crazy random data. So that should wrap up the actual assets that Rocket Lasso has already created. Let's open up a new file and then oh yeah, actually, when I was stress testing the graph, I also made this render. I just want to show that. It's kind of putting all those different types of graphs behind kind of a tinted pane of glass, and the combinations and the ways that these combine are just so much fun. I love these little circle ones, and this is using just 180 degrees of it and layering up different types of noise on top. This is putting them into a cloner and then having them push back slightly, and then the glass is blurred, so they blur as they go further back. A lot of fun to combine these things. Anyway, before we get into individual nodes, let's move into the asset browser again, clear out our search, and then let's move into nodes. So here's all the different node types. Much in the way that Rocket Lasso has put together that grid primitive and the new graph primitive, there are a sprinkling of other ones that already exist. And we can find those by going into the geometry generator inside of nodes. And the way I actually find this, you can actually go into the geometry primitives, but there's a lot going on in there. So if you go into a geometry generator, I can grab this spline primitive and pull it in. And this is an unusual object as far as the way it works in nodes, where it's sort of the master object. It's like this is every type of spline. So you'll see that there's a primitive type. If I click that, we get a drop down of every type of spline. So there is a couple in here that are pretty useful, and there's a good way of finding them. So now we can see that there is something called a 7-segment display. There's something called the circular arrow. You can actually see that here is the FUI graph and the grid. But in addition, there is also the segment. And here's a test spline that I made. So there's 3 different types that we should check out. We've got a segment and circular arrow and 7 segment. So instead of making it from there, I'll delete that. And under the primitives, we can find those individual objects, but you can also search for them. So I found one right away. So here's the 7 segment display. It's been in there for a little bit, I believe put together by Rick Barrett, and only a couple controls, but you can make these 7 segment displays. We can type in any numbers we want inside of here, and it's going to display that number. We could set the time, so set to 3:33, and you could put the colons in there, and it will create the 7 segment display for you. So that is a primitive already there, ready to go. You just wouldn't know it because it's not living inside of this spline dropdown yet. I'm looking forward to the point when the nodes are mature enough that all of the stuff gets migrated directly into these menus so that they can become useful there. So that's a 7 segment display. Another one we saw was the segment. And the segment is just a standalone spline. I search for segment, drag that in, and this is just a straight line. I'll hit S to zoom up on it, and yep, a single line pivoting from the center, 1 point there, 1 point there. Something we've never had in Cinema. We had to change a bunch of settings, but there it is. We can set the length of that. We can change the offset to be pivoting from the negative X or the positive X. We can change the point count and heavily subdivide that. So there's now 32 points making up this overall line. So that can be pretty handy. This is currently set to linear mode, but there's also a Bezier mode. Setting that to Bezier, let's default that back to the middle. And now we get a start angle and a start strength, so we can add a bit of a curve there. You have to imagine the tangent line, you know, when you're playing with a basic spline. Let's just draw one. So let's draw that here. So if I were to draw that handle out and this handle out, hit escape and just select this. If you were to be moving that handle up and down, rotating it, that's essentially the parametric version right here. So we can set the angle to point it up or down, and then we can set the strength to push the handle out further or shorter, and we can do that both for the start and the end. So it's a parametric workflow now that we could feed into any rig, blend between different ones. In fact, let me show you. If I put that into a cloner and set the cloner to linear, so we should get a series of them cloning as they move upwards. So I'll just separate them a little bit. So I had a bunch of copies. I can now add 2 of them and put different settings in them, and as long as I set the cloner properly to blend, then now we are blending between these 2 different shapes and however we want to lay them out. So yeah, having this line be parametric does open up a lot of opportunities for very controllable rigs. And then the last one we had, let's see, what was it, arrow? Yeah, circular arrow. Needs an icon yet, but yeah, here's a circular arrow primitive that we were able to set a start angle and an end arrow and set the width. And there's a bunch of different ways that you can set the tip to look. So yeah, additional tools that are already built in, new spline primitives that just haven't been integrated into the menu, but for the most part, they are ready to be moved over there. So keep in mind that that type of thing does exist. Deleting the arrow, let's get set up for diving into some geometry modifiers, or these are just geometry nodes. The first thing I'd like to do is set that to be a list view, and usually they're a little bit larger. I like shrinking it all the way down so we can just read it as a list. In order to see the modifiers in action, we need some sort of geometry. So in the polygon objects dropdown, I'll create a platonic, change the type to a buckyball, which has always been one of my favorites. Hitting NB, we can see on the edges that even though each of these flat faces is 5 or 6 sides, we can only display quads or triangles. So there's going to be these subdivisions. That creates a problem if you're going to do some sort of parametric modeling, or maybe you want to clone onto these and clone onto the center point or something like that. So let's do it via a MoGraph MoExtrude. And this is a parametric extrusion that can be driven via effectors. Dragging that as a child, you're going to see that every single polygon is extruding out in 4 extrusion steps, but it's every single individual polygon, and that is not what I want there. So turning that off, we can parametrically clean this up via going into the geometry modifiers. In here, these are nodes, but when I select, let's say, untriangulate and drag it in as the first child of the platonic shape, we can turn on create n-gon, and now procedurally, parametrically, we've gotten rid of those and created the n-gons. Now that that is happening as a modification to the direct geometry, now we could turn on that MoExtrude, and you see we get very nice clean extrusions. Now, inside of these modifiers, you'll see a lot of different modeling operations that you're probably familiar with. A bunch of these we already have. Some of them we don't. One we're familiar with maybe would be smooth points. Drag that in as the third one, and you can see everything's getting smoothed out. I could pull back on the strength or the iterations, making it nice and smooth. Very similar, although not identical, to the smoothing deformer. They have slightly different algorithms. But then there's other ones that we have never had before. And one of them is this very handy geometry axis. By grabbing that and making it the last modifier in the stack, you're going to see that what it's doing is looking at the bounding box of the object, and we can now offset all of the geometry. In this case, I'll pull the geometry way up, and now you see that the axis is at the bottom. This is now sitting properly on the ground with all the geometry moved up while being entirely parametric. So we can always go back to that original object, make any change to the radius, and it's all pivoting perfectly right from the baseline. This is not something we were able to do inside of vanilla Cinema 4D, and now we can by dragging in a node as a capsule. For the next modifier, I would like to talk about geometry resize. For this, we're going to need several objects. I could, let's just grab this one and scoot it off to the side a little bit. I could create a cube and shrink it way down, and let's scoot that off to the side. Just for fun, I'm going to open up some gemstone models that I created. So searching for the word gem, here's a list of gemstones by Rocket Lasso, and we sell those. So selecting all of these, I could say load them into the scene file. So here's a whole bunch of different gems. You'll see they're very small. Going to object mode, I can select all of them and line them up nicely by typing in num, which is the index of an object, times 3 because they're really small. And now you can see all of these nice gemstones all lined up in a row. So here we got a bunch of different objects of vastly different sizes. Some very close, some huge. So how about we create a node, clear out the search. We're going to want a geometry resize. To do this, I'm going to make a null, select everything and make it a child of the null, and then drag in the geometry resize into the null. And now everything should be getting modified. I would like to say that the target size is 2 based on the Y height. And now if we zoom up, we can see that every single one of these objects has shrunk to be exactly the same height. We can select the cube, scoot that over, and now we've got all these individual objects all exactly a height of 2, all thanks to this modifier. Each object, it's their actual physical geometry that is shrinking down. It's not modifying their coordinates and their scale. It's like, no, the geometry is what is changing. If we were inclined, we could drop this individually as children into each one. So those could be directly set each. Let's drop down to the giant object. We'll make it the last modifier. You see that shrunk down. I'll get rid of the cube. We don't need that one. So yeah, that has shrunk down to be exactly its size, but the original object is not modified. Delete that object. Let's take a look at maybe one more modifier. In this case, let's grab one of these. Let's grab the diamond shape. And what I would like to do is, let's reset that to 0. So reset transform, zoom up on it. So here's a diamond, and I put nice UVs on each of these. And there's another modifier here that we can use called UV to mesh. If I drop that on the object, we're gonna see it kind of disappears there. But if we hit the letter S, zoom up on the selection, you can see here is the actual final object. It has taken the final UVs and translated them to the actual geometry here in the scene. There is one input here, which is the overall scale, so I could shrink that way down. But now that is the UV translated into the real geometry. Very fun, very powerful. This can be applied to anything that's got nice looking UVs. We could search inside of here for, I don't know, let's search in the model category. So I'll say objects, and I would like to go into food, and let's see what's a good one. Let's grab the walnut. So we'll drag a walnut instead, and let's steal this and put it onto the walnut. And you can see there's the UVs for the walnut. Again, just a nice little tool that I wouldn't have known how to do that otherwise, and now that opportunity has opened up. Back into the nodes menu and into the modifiers, geometry modifiers. Again, what is important to note here is that all of these exist independently as a node for working within Neutron, but in R25, they unlock the ability for those to be dragged directly into the object manager, creating direct usefulness right now that we can directly be jumping into. So why don't we take a look at just a little bit more when it comes to maybe making multiple modifiers and also add in the concept of selections. I want to step through a little bit and talk about the way you should think about these though. Right now, if I were to select the polygons of this object, you can see that whenever you make a new object in Cinema, be it a cube and you make it editable or any other shape, when you make it editable, nothing is selected. But if I were to hit the letter D for extrude, and extrude right now, oops, let me not click so that there's nothing selected. So if I click off the object, you see that everything is extruding. If I hit MS, the shortcut for the bevel, and click with nothing selected, everything is affected. So what that means is when nothing is selected, you should also think of it as everything is currently selected. As an alternative, of course, if I had one thing selected, only that gets applied. You have to keep that in mind when you're working with some of these procedural modeling techniques that are unlocked with capsules. So hitting undo, let's say we just want to do something real simple. Let's say I want to do an overall inner extrude on everything. Let's deselect all the polygons and then select a inset. So with the inset, you see every single, even though nothing was selected, it's like everything was. The current selection is default being nothing, but nothing still gets everything applied. Let's not do proportional. Let's instead make it an absolute, make this really small, like 0.1, very small inset overall on this very small object. Awesome. So now everything's done in inset, but now I want to delete. Let's delete everything that's on the inside there. Now delete, get that as the second child. Everything disappears. Why did everything disappear? Well, we had nothing selected. And if nothing is selected, then it applies everywhere. So how would we change this order of operations a bit? Let's turn off those modifiers and now move into the geometry selection. What I would like to do is select something. So let's say I would like to select, what would I like to select? I would like to select all. So now every polygon is selected. We don't get to visually see that. We can't tell that it is, but we know we just said select everything. Now, when I do an inset, the exact same thing looks like it happened. Everything got modified inward, but that's because everything is selected now. But now when I hit delete, this time we are left with just these holes and the rest of the geometry is remaining. So what is the difference there? Why did that work? Well, let's step through what that would have looked like otherwise. If I select everything, hitting I for inset, let's scale these down. And now you'll see that only those polygons are selected. And when you're using this via the nodes, via the capsules, the exact same thing happens. If these are what are actively selected, then that means that the delete, when I hit delete right now, will leave everything else behind. So keep in mind the way selections work because it's actually really, really important. So far, everything we've done has been very meticulous, very straightforward, step by step. And the reason we're doing it that way and keeping it simple is if you pop open an existing node setup, it can look really complex and intimidating. For instance, all of that graph stuff I was showing earlier, if I open that up and we actually go inside of the nodes and I show you, let's move inside here. Here is everything needed to some of what is needed to start making this graph. And inside of here, there's a lot of groups that are containing even more information, more controls. So there's groups within groups. It can get super crazy. That gets intimidating. So that's why instead we're keeping this nice and simple as we step through. Let's go back to our standard layout. And I would like to deselect everything so I don't have any polygons selected. Let's delete those modifiers we already created. Pop open that asset browser again and shrink that to a nice readable list. So how do we go about creating our own modifier capsule out of nodes? Well, over here inside of our nodes folder for asset construction, here is a bunch of different capsule types. The one we are specifically interested in is the geometry modifier group. I'll drag that in directly as a child and nothing's going to happen. And that's because if I double click on this modifier group, you're going to see that it is empty. There's nothing inside of it. It has popped open a node editor window for us. And what do we get when we see this? Well, there's geometry being fed in and there's geometry being fed out. So we need to interject some nodes in here to make it actually do something. So let's essentially recreate what we just had before. We'll begin by going into our geometry modifiers. And what we like to do, let's do an inset. So dragging that in, here is a node. Now before we were dragging that into the object manager, which turned it into a capsule, but here it is represented directly as a node. Now what does this node want? It wants geometry, and it's going to output geometry. As soon as I do that, move this window, you can see the inset has appeared on the object. This is a single node modifier, and we could stop right there if we wanted to, but of course, let's make it more complex. The next step was we want to delete that inner polygon. So we can drag the delete, but remember we need that proper selection going on to make that work. But let's do it wrong to start out with. If I select the delete node and drag it in, I can actually drop it directly onto this wire, and it will interrupt that. And now geometry will flow in and then out of that because the nodes were smart enough to know where to put that. So pulling this up, everything disappeared. But we were expecting that because currently, based on the selections, everything would get deleted. So doing the exact same steps we did before, let's go into the geometry selection, find a select node, interrupt this wire. And what do we want to select? I want to select all. So with everything selected, the inset properly works. And then only that inset was selected, which means it then gets deleted. Now, at this point, nothing is selected because we deleted everything that was selected. But let's add a little bit more onto here. In this case, I would like to add on a geometry modifier. There's something called solidify, and essentially that will add thickness onto a model. So in this case, adding a solidify, I missed. Let's connect the geometry in and the geometry out. And the instant we do, it's going to kind of explode, but that's because there's a lot of thickness and this is a very tiny object. So let's set that down to, let's say 0.1. And now we have a model that has thickness. So stepping through here, we've got a single modifier group that is containing a bunch of nodes that do a whole bunch of different things to our geometry. And we could just keep on adding to this chain, changing and modifying the geometry as we go and creating crazier and crazier effects. Let's try pushing this even a little bit further by creating some controls for ourselves. I see two obvious controls that we can do. And one will be this inset percentage. So how would we propagate that out? Well, selecting this inset, you can see we've got this little dot that we can click, and that is going to ask what do we want to do, and I would like to connect the node. Where? I would like to go to an existing, and then say I want to add a new input to the root. So by clicking that, it's going to create a brand new wire that propagated out into this input bar. Now, under solidify, we've got this thickness. I would like to do the exact same thing again. So selecting that, I would like to connect it to an existing root, add new input, and now it's created a brand new one there. Selecting the geometry modifier group as we've made it, we now see we've got two different controls that we can click and drag. And as I modify, you see that these are going to get larger and smaller. Now, currently the slider is like way overdoing it. We want to be really subtle with those changes. So we can spend a moment if we want to and go and edit the resources to change the way these are layering out. We can do that by right-clicking on this input bar and say edit resources. Now, this is going to look a little bit intimidating. There's a lot going on here. And as I select things, you're going to see it looks even crazier. Right now, we've got an input called thickness, and then here is our inset. I'm going to move this inset up next to the thickness. Actually, we'll put the inset first. That'll be the first thing that comes in. Selecting the thickness, you can currently see that there is a slider, and we are limiting the value from -50 to 50 with a step of 1. That's way too huge for our purposes. So let's say that this can go anywhere from -1 to 1, and it does tiny little steps of 0.1 as it goes. So now you can see that these two sliders have lined up. We get a nice preview of the settings up here. So now you see if I click the thickness, I can only drag it from -1 to 1 in much smaller increments. Closing that down, I would like to save the database. Now this slider should be a lot more reasonable for controlling this thickness. So let's close down that node for a second and look at the two controls we gave ourselves. We can shrink that and grow it all the way up to 100. And we can change the thickness of this overall. And keep in mind, we only clamped the slider, so we could push that beyond that amount if we want to. But we want to keep this nice and subtle, nice and small. So that is all working great. We've got these nice simple controls in our own modifier. So what would we like to do with this? Well, first I'll rename this to inset with thickness. And then why don't we save this into the asset browser? We can do that by double clicking on our nice little modifier group here. And then with nothing selected, I will go to asset, convert to asset. That's going to pop open this save asset. It's going to have the name that I titled it. We can save this into my preference folder if I want to. We can give it a version number. We can put it into a particular category. In this case, it is in a category. So if I click on these dots, I could say this is supposed to be a node and it's supposed to be a geometry modifier. So we've now given it a classification. hitting OK, that should now save it. And the instant I just saved it, it has now created this inset with thickness inside of this menu. It now exists directly inside of this group with everything else. So closing that down, I could delete this. In fact, let's just open up a brand new file and open up a different model. Let's make a figure. I'll make it really small because we were working with a small scale before. So there's a tiny little person. We'll set that to 10. That seems reasonable-ish. And then drag this inset with thickness onto it. And now inside of just my Cinema 4D, that asset now exists to apply onto any object that I want. Let's turn on some limit on the Fong, and there we go. It's applied automatically to this character. Selecting the inset, I am able to change the percentage, and we can change the thickness as it's applied onto this figure. And that is the entire process for creating my own modifier that can be used on any object, anywhere I want to put it. As a final detail of creating our own assets, we could right-click on this new inset with thickness, show the details, and add additional information if we want to. So dragging this up a bit, we could change the name, we could add annotations, we could add in some keywords if we want to make it even more searchable. We could modify the version number as we make different versions. But something I think is really cool is if you want to add your own custom icon, we can do that however we like. In this case, why don't I modify this to be nice and subtle, just 0.1 on the thickness. And let's even make that a little bit skinnier there and zoom up on some part that should pop out a bit. Let's say the head there, and then take a screenshot. So I'll hit Windows Shift S is a shortcut on Windows to create a little screenshot. I'll try and make that about square. And now if I were to right click on this blank icon, I could say update preview from clipboard, or if you had it saved somewhere on your computer, you can update from a file, but I'll paste it from the clipboard and there we go. That is now the icon. And you'll even see if we get rid of that, that is an updated icon on the actual inset. So you could design your own ones really, really easily. And that just sort of completes out making this nice and clean and ready to be used. So just a nice way of completing the entire process of making that asset for myself. And with that, that wraps up my presentation about practical uses for nodes right now. I would like to remind everybody that Rocket Lasso Live is back next week on Wednesday. I'll be answering questions live on Twitch and on YouTube, all about Cinema 4D, tackling all sorts of crazy things. Looking forward to that. It's always different every single episode, every single season. It's a lot of fun to dive in and just answer questions when we don't even know it's going to be coming. A big thanks to everyone for watching, and a thanks to Maxon for having me again as always. And finally, you should of course follow Rocket Lasso on all the different platforms at Rocket Lasso. And if you go to youtube.com/Rocket Lasso, that's where you can find a whole bunch of live streams, the upcoming live streams, and presentations and tutorials from the past. Thank you so much for watching, and I'll see everybody next time.